Okay, so in Math 20, you looked at circles and you worked with tangent lines. You know that a line drawn tangent to a circle touches the circle at exactly one point. In 4.3, we're going to study the slope of lines that are tangent to curves at a certain point. We're going to develop a definition for this using limits that we learned in section 3, or unit 3. In this section, we'll be able to determine the slope of the tangent line precisely without the use of a calculator. Okay, so let's have a look at this 4.3. Okay, we remember that the slope here is equal to the change in y, or the rise, over the change in x. So when we look at this graph, specifically at point P here, we can see that P happens at an x value there, and the y value is f of x. We can also see then point Q here, and if we add h to x, we see that Q is happening at the x value of x plus h, and that leads to the y value here of this certain distance h plus the original f of x. So when we put x plus h in here, we get this value. We see that this is the change in y, and the change in y, where we find the difference here, would be f of x minus h subtracting f of x. That's the difference here between the y's. And same thing, this is the value of h. You can see the difference, x plus h subtract x would just be h. This is our delta, or a change in x. Now what happens as h approaches 0? So as the distance between points P and Q here, this h, gets smaller and smaller, what happens to the slope of the line PQ here? So if we think of that, if this distance getting smaller and smaller, so if now Q happens to be here, and we are finding this slope, as Q gets closer, as h gets smaller and smaller, Q gets closer to P, and we find that the tangent here of PQ is going to get closer and closer to the tangent of just P. The slope of the tangent line would approach the slope of the tangent line at P. Pause it and think about that for a second. We're going to start using the word derivative. The definition of derivative is the slope of the tangent line at any point, so any x value, on the graph of a function. So if I just drew this function right here. So if I would pick any point, say this x value here, the derivative means the slope of this line, this tangent line, at that point. Same with here. If I would pick this point down here, the derivative of this point is the slope of the tangent line at that point. Here we go very hard on a straight line, but if I would pick this point, the derivative of that point on this function is the slope of the tangent line to that point. There's a couple different ways to write the derivative. This first way here, we see dy divided by or over dx. So we say dy over dx, or we say dy with respect to dx. Another way to write the derivative, we use the symbol prime, just the apostrophe on the keyboard. We say this f prime of x, meaning we've taken the derivative. We've found the derivative of that function f of x. Another way, we know that f of x is replaceable with just y. So another way here is to say y prime, or the derivative of the function y. Okay, here we see the function f of x, defined as this parabola opening down because of that negative x squared there. We're asked to find its derivative. So what we're essentially saying here is we want to find the slope of any the equation of the slope of any tangent line to this function. Okay? So we know the slope is the change in the rise over the change in the run. So we know the rise here, here's the change in y. Remember this new value, subtract the old value, over the change in x. This is the difference here. This new value, subtract the old value, just h. Okay, so we're going to use limits to do this because we want the limit as h is going closer and closer to 0. So as this distance is getting shorter and shorter, what is this tangent line here? So as limit's getting closer to 0 of the change in the y divided by the change in the x. Okay, I'm going to stop the video and work this out, and then we'll walk through it. Okay, so we took the function f of x, that's here, and we substituted in x plus h everywhere there's an x, here and here. That's this first function. Then we subtracted the f of x, whoops, that's dark, here. This is f of x, here and here, for f of x. Okay, and that's all over h. So now we have to go simplify this out. We should be able to cancel these h's like we've learned in limits unit 3. Okay, so I multiplied everything through. I canceled out common terms that canceled out. I was left with this. Out of the numerator here, I factored an h. The h is canceled out. And so here reduced. And then like we did in unit 3, we're going to use substitution, just putting in 0 for h. And we will get the answer here of the derivative will be 4 minus 2x. Okay, so this is the slope of the tangent line at any spot, any x of this f of x, of f of x, okay, of this function here. This is the equation of the tangent line. This is the derivative, okay? So then, what's the slope of the tangent line at this point, where x is 4 and y is 5? Well, let's write it a different way now. F prime, the derivative of, well, in this case x is 4, is going to be equal to, here's our function. So instead of the x, we're going to put in the 4. And we find that at this point on this function, the slope of the line tangent to this point, the slope is -4. Ding, ding, ding. Easy enough. Where is the slope of the tangent line? -6. Okay, well, f prime, at what x value is our slope of that line going to be -6? Well, f prime of x is equal to, what did we say, 4 minus 2x. At what's x value there? Well, if I solve that out, x is going to equal 5. So when x is 5 at that point, the slope of the tangent line of this function is -6. Looking at number 2, we've got a new parabola here. This opens up. I'm sure you could sketch it out if you wanted to. What we're looking for is the derivative of this function. We're looking for the slope of any tangent line to it. And we find that by finding the limit as h goes towards 0 of, again, you can refer back to this very first drawing if you want to, of f when we put x plus h in for x, subtract f of putting x in for x, all divided by h. This is a huge, long, same as we did number 1. Stick those in for this function, solve it out, find the equation. I promise you we're going to learn in a lot easier way to find the derivative. But for now, we're going to do it the long way. You do the work. I'll show it to you and with the answer at the end. So press pause here and do the work. Okay, so I multiplied everything out, canceled an h, put a 0 in for h, and found here that this is the equation of the tangent line to that function. This is f prime of x. So, once we know that, what is the slope of the line at when x equals 1? Okay, well, f prime of 1 means that we take f prime here and we stick a 1 in for x, and we find that the tangent, the slope of the line tangent at 1 is going to be equal to 2. Okay? And we can also find the equation of the tangent line at 1 simply by using this slope-intercept form, y equals mx plus b. This is everything you did in section 1. We know that the x is equal to 1. That's here that at 1. F prime of 1 is the same as the slope of that line, right? That's the derivative. We just found that to be 2. Now we need to find y. What's the y value at this point? We can do that. And we need to find b. We can do that too. Stop and you can do the work, or I'll show you in a second. So to find y, we put 1, the x, into our original function. That's at the top of the page. And we get y is negative 3. There's our y. When we know that, we can find b. Here's the equation. We put y in, we put the m, we put the x. We solve for b is minus 5. So our equation then of that tangent line is y equals mx plus b. And it doesn't say in general form, so that's good enough. Okay, here's the work. Remember, you've done this in Unit 3. Here we put a 2 in, and then we're asked to find the equation. Pause it and see if you can figure this out. Okay, here's the equation of the tangent line. Again, we're given x right here. We've found the slope right here. You calculate the y by putting the x into the original function. You calculate the b by putting everything else into the y equals mx plus b. Find it, and then you can substitute in the m and the b into the slope-intercept form. Is the slope of this tangent line ever positive? Well, here's the slope. I wrote it again from up here. Here's the slope. Any x we put in, we square it. We divide by that by negative 10. Nope. This slope of this tangent line will always be negative, going downward. Good question. Where does a function not have a derivative? We see that there's not a derivative at a corner or a kink. So if ever the function comes to a point, turns a corner, no derivative at that exact spot. Okay. We also see that a function will not have a derivative where it is not continuous. So if it's got a point of discontinuity, there is not a derivative at that point. And we see, lastly, I should really change my color of crayon. The tangent line is vertical. There will not be a derivative. Straight up and down. We found out that vertical slopes are undefined. So when the tangent is vertical, we'll also see no, not possible, no derivative at that point. The last example is from page 174. I've written it out and I've drawn a rough sketch here. So what's larger, the question is, f of 0. If we find f of 0, we see the answer is negative 2. F prime of 0, we're looking for the tangent line, the slope of this tangent line. The slope of this tangent line right here. The slope of that line? 0, right? We know a horizontal line has a slope of 0. So the larger one here, this. F of 3, okay, if we look 3, oh, that was way off. 3 was about right here. I think the answer was supposed to be 1. Again, my drawing's a rough sketch. If I go over, this was supposed to be 1. Doesn't really look like it, but that's okay. The f prime, so now the slope of the tangent line to that, well, it is that. So if I would find the slope here, 3 down, 2 over, negative 3 over 2, I would say the slope, the larger slope here is f of 3, 1. You can do C on your own, and you can see the assignment there. Okay, make sure you text me if you have any questions, and sorry about the long video. I hope it made sense to you.